Hi, let us continue with our discussions about the curtailment of reinforcement. In the previous videos, we mentioned about two methods of doing curtailments of reinforcement in beams. The first one is the simplified method. The second one is the Eurocode method. The two methods work out the amount of reinforcement and curtailments of the reinforcement based on the tensile force diagram derived from the bending moment diagram using the formulas of NED per C. The reinforcement should provide sufficient resistance withstanding the tensile force along the beam span, and the reinforcement may be terminated at regions which is unnecessary, provided the resistance is always greater than what is required, as reflected by the shifted envelope diagram. On top of those, there are several additional curtailment rules. In terms of the minimum amount of reinforcement bar to be extended to the support, as well as the reinforcement bar required to maintain the level of fixity of the end support, as well as the lapping of the reinforcement bar in the internal support. Now, if you observe the fundamental approach, the process is tedious. It is custom-made by beams, being influenced by the loading acting onto the members. Due to different magnitudes of the loading, as well as different types of the loading, the bending moment diagram may differ, which later you will need to do a conversions from the bending moment diagram into the tensile force diagram, and then you need to work out the amount of reinforcement bar provided, check the resistance provided by the reinforcement, make sure it is always greater than the shifted tensile force envelope. Imagine now you are designing an entire structure. Different beams needs to be custom made with different curtailments applications. This makes the work to be more tedious than what you can imagine. This leads to the needs of the simplified rules, which we can base on for us to make a quick curtailment process in order to speed up the detailing process. Now bear in mind that the simplified rules for the curtailments that we're going to discuss in these videos is not provided by the Eurocode. Eurocode approach this in the fundamental manner. Now, where can we get these simplified rules for the curtailment? You can get it from the British Standard at 110, figure 3.24, which is applicable for the beams, and figure 3.25, which is applicable for the slab. Let's say now we focus on the simplified rules for the beams. You need to be careful if you are using these simplified rules for the British Standard, because at the first place, it must fulfill the two conditions. First, the beams are supposed to be designed predominantly uniformly distributed load. Second, in the case of the continuous beam, the spans are approximately equal. Now, if you have point loads, or if your continuous beam, the span varies significantly, the simplified rules given by the British Standard is theoretically not applicable. Now, let us look into the curtailment rules given by the British Standard at 110. Let us first deal with the simply supported beam. Simply supported beam here deals with the bottom reinforcement bars. You need to design the amount of reinforcement bar sufficient to take the maximum moment along the span, and that specific amount of reinforcement constitute 100% of the reinforcement areas. Near to the support here, you may reduce the amount of reinforcement bar by 50%. Now the question here is where you can start curtailing your reinforcement. we are looking at a distance of 0.08 effective span. And if in accordance to the British standard, this 0.08 L shall be determined on the basis of the half of the bearing areas of the support. And then it specified an additional of 12 times the bar diameter or equivalent anchorage length to ensure the reinforcement is fully anchored inside the support. Now, if you find this difficult to imagine, you may refer to this. Simply supported beam, 100% maximum steel bar at the midspan, and then you may reduce the amount of reinforcement bar by 50% at the locations of 0.08 L, which is the effective length of the beam, calculating from the centroid of the support, which shall not exceed the distance of D per 2, with the D here referring to the effective depth of the section. And then you need a full anchorage length, which is at least equivalent to 12 times the bar diameter. Next, we talk about the continuous member. Continuous members, you have two groups of reinforcement. There are top reinforcement and also bottom reinforcement. This represents the internal support of the continuous member, where you have hogging moment at the internal support. The top steel bar is designed to resist the maximum hogging moment at the support, whereas the bottom steel bar is designed to resist the maximum sagging moment at the midspan. There will be 100% of the top steel bar placed near to the support at a distance of 0.15 L or a minimum of 45 times the bar diameter. You may reduce the reinforcement by 40%, and then exceeding 0.25 times the effective length, the amount of top reinforcement may be reduced to 20% only. As for the bottom reinforcement, this represents the midspan. The 100% bottom steel bar is to resist the maximum sagging moment. Towards the support, the amount of reinforcement may be reduced to 30%, and curtailment can be done at the distance of 0.15 times the effective length from the support, with this distance not exceeding the D per 2, which is half of the effective depth of the section. Now you need to be careful with the locations of the curtailment. First, if you are talking about the bottom steel bar, we are talking about the centroid of the support. However, if you are talking about the top steel bar, the distance is measured on the basis of the face of the support. Now, if you find this diagram difficult to imagine, you may refer to this. This is the internal support. And the one which is given in the British Standard at 110, it will be this part. You have bottom reinforcement, taking the sagging moment. Near to the support, you may reduce to 30%, with a distance from the centroid of the support of 0.15 times the effective length. As for the top steel bar, you need the steel bar to resist the hogging moment at the support at the distance of 0.15 times or at least 45 times the bar diameter. You may reduce the amount of reinforcement by 40%. Exceeding 0.25 times the effective length, you may keep 20% remaining of the reinforcement. Now, the length here is measured from the face of the support for the top steel bar. As for the bottom steel bar, it is measured at the centroid of the bearing support, which should not be greater than half of the effective depth. Only that, at this end, it will be 0.1 times the effective length, as clearly indicated by the British Standard Act 110 here. That means this length here at the end support, it will be slightly shorter. That gives you the layout of the reinforcement, something like this. Next is the cantilever. Here will be the support, and this will be the cantilever length. Cantilever beams here, we are looking at the top reinforcement. You need to design your reinforcement in order to resist the maximum hogging moment. And then at a certain length, you may reduce the amount of reinforcement by 50%. And this length shall be equal to L per 2, or at least 45 times the bar diameter. Again, the effective length here is defined from the centroid of the support, but it should not be greater than half of the effective depth. Now, if you have difficulty to imagine this, you may look at this one. This will be your cantilever effective length, measuring from the centroid of the support, which shall not be greater than half of the effective depth. You need to provide 100% reinforcement bar near to the support, within the regions at least half of the length of the cantilever beam, which should be at least greater than 45 times the effective depth. Only then you can reduce 50% of the reinforcement. Now, your tension reinforcement on the top of the beam will need to be continued towards the adjacent span. You cannot leave the reinforcement simply anchored in the member, something like this, in order to ensure the stability of the cantilever beam. What you see here, this simplified rules is not really given in the Eurocode 2. It is still popularly used among engineers due to its simplicity, especially if you use the Eurocode method. The calculation process, it will be more tedious, but it is more accurate. Now, if we revise the curtailment rules while adopting the fundamental approach, we see the minimum requirements of at least 25% of the bottom steel bar to be extended to the support. What is provided in the simplified rules here is always greater than 25%, which is okay in this aspect. And then if you look at the requirements for the end support here, for fixed end and also for pin end, we are looking at the bottom steel bar and the top steel bar. And they are also looking into at least 25% of the reinforcement. Plus, for the simply supported, you need to provide resistance to 50% of the shear loads. Probably you might need to check for this. I believe this is the reason why the simplified method specifies this as the 50% instead of 30%. Although you know that by fundamental, you cannot equate this 50% to the tensile resistance to the 50% of the shear loads acting at the support. Probably you can check on this. And then one more thing, these simplified rules given by the British Standard cannot be universally used in all cases. There are conditions which the loads have to be predominantly uniformly distributed. And for continuous members, the span should be more or less equal. Now, if these conditions is not applicable, there are two options that you can go with. One is dealing with the fundamental approach, either the simplified method or the Eurocode method. Or if you still wish to maintain the simplicity, probably you just forego the curtailment. Just that you had to pay extra careful with the potential congestions of the reinforcement at the support. I see in some references, they add up an additional requirements for the applications of these simplified rules, which they require the characteristic variable actions not to exceed the characteristic permanent load. You may also adopt this requirement if you wish to apply the simplified rules. However, since this requirement is not specified in the British Standard, personally I will still stick to these two conditions. Lastly, bear in mind that this simplified rules is applicable for beams. As for the slab, the curtailment rule varied slightly, which we're going to discuss about it in our next video. Stay tuned.